Alright, check it out, guys. Here's part 2. We just finished part 1, ending on this here question, going up to number 8 about whether neither are quadratic, linear, or exponential. I should say linear, exponential, or neither. So here's something kind of a weird skill. We're talking about ordering from least to greatest. In other words, we're definitely trying to order this guy from the smallest number to the largest number. But we really need to develop a strategy, which is really what question 10 gets at. So I'm going to do that first. If you're looking at these numbers, I think the hardest thing to do in terms of ordering is just because everything looks weird. I think for me, the strategy is going to be that I need to change all these numbers so they look the same. And they need to look the same in terms of something that I can order very quickly. So you really have two choices, I think. You can really make every number look like this, which is option 1. In other words, make everything in decimal. That way you're kind of looking at them in what we call standard form, which is something we're totally used to. That's something we deal with numbers in terms of pretty much our whole lives. Or option 2 is you can make everything look like this, which is scientific notation. And for me, that's actually going to be easier, I think. So I'm going to go ahead and make these scientific notation numbers. Now, and on the second set, I'll do it in standard. And the reason I want to do this in scientific notation is because if it is all in scientific notation, I can just look at the powers of 10, and that can be my least to smallest numbering. So let me kind of demonstrate what I mean. So in this option, we're going to take everything and make a scientific notation number. So 20 squared, that's the first thing that needs to go. Okay, so 20 squared is going to be 400. In other words, 4 times 10 to the second power. So let me show you how I did that. 20 squared is just going to be 400. I move that decimal point twice. That's where I get the power of 2. So I end up with 4.0 times 10 to the second power, because that's how many times I move that decimal place. Okay, so that's how we're going to change these numbers around. Now, this actually is in scientific notation. This E, what you see on your calculator in print, there's nothing mysterious about that E. That just means times 10 to the negative 5th power. So if you don't like the way this is looking, I can change it. 3.39 times 10 to the negative 5th is all it really means. Now right there, this kind of shows you that I can order these very quickly from least to greatest. This by far is the smallest so far because the power of 10 is a negative 5. This would be the second smallest. They're both 2's, but 3.29 is smaller than 4. So that's the next smallest. That's the largest out of the set I have so far, excuse me. But anyway, let's go ahead and scientific notation this whole set. Now check this out. 1, 2, 3, 4, 5 places, but going backwards means in scientific notation this is 5.29 times 10 to the negative 1, 2, 3, 4, 5 to negative 5th. 4e to the 6 is just 4 times 10 to the 6 if you want to see it that way. This has moved 1, 2, 3, 4, 5, 6, 7 places. So 3.29 times 10 to the 7th. Let me recount there. 1, 2, 3, 4, 5, 6, 7. Yeah. And 40 million, well, that's not so bad. We just have to write it out first. So that's 40,000. That's 40 million. So in scientific notation, I'm going to move that guy 3, 6, 7 places. So this turns out to be 4 times 10 to the 7th. Now we should be able to order these actually relatively fast. All we have to do now, let's go purple. All I have to do now is look for the smallest decimals, and if they tie, like in this case, I'll look for the smallest coefficient. So 3.39, 5.29. This guy is definitely going to be first. So I'm going to write it in its original form. So 3.39 E negative 5 goes first. Okay, so next smallest coefficient, or I'm sorry, power would be this again, negative 5. But since 5.29 was bigger than 5.39, that goes next. So 5.29. I'm sorry. Let me write it in its original form because that's what I said I was going to do, and that's what's proper to do on a test. So this would be 0.000529. Okay, what comes next? Smallest coefficient. Well, that's 6, 7, 7. So let's look at the 2's. Now these are tied, but 3.29 is smaller than 4. So 3.29 times 10 squared comes next. And then 20 squared is the next number. Now this is a clear winner. 4 times 10 to the 6th power. And now these both have 7's, but again 3.29 is smaller than 4, so that comes next. Oops. I had to write this form. So 329,000,000, and the last would be 40 mil. Okay, not so bad. Again, think about the strategy and turn everything to scientific notation first, then compare the powers. Now, if you want to see from the other side, you can. The goal here is going to be, let's turn everything into like the standard form. So if you didn't like the scientific notation thing, no big deal. Not everybody does. What I would suggest then is take all these numbers and make them like whole numbers or decimal numbers. In other words, standard form. Now this one's already done, so I'm not going to touch that. 5.5 e to the third. Well, check this out. What that means is times 10 to the third. Bump that guy over 3 times. That's what that 3 means. Fill them in with zeros. This is 5,500. 5.5 times 10 to the negative third. So 5.5, 10 to the negative third means bump it this way 3 times. Fill those guys in with zeros. So that'll be 0.0055. Okay, 55 billion. Well, 55, and I'm going to run over in here, but that's going to be okay. So that's 55,000 million, and then billion. So it's million, billion. Okay, 0.55 is already done for us. And then 55, and then negative 5. So that's going to be 1, 2, 3, 4, 5. Okay, so 0.00055. Okay, so now when we're ordering from least to greatest, it should be pretty straightforward. I have 3 decimal numbers, 0.55, 0.005, 0.00055. This guy is the winner as being the smallest. So I'll write in its original form, 5 times 10 to the negative 5th. Okay, next is going to be this guy. So 5.5 times 10 to the negative 3rd. And I think these are a little bit more obvious because, I mean, this has more decimal points between that and the 5s than that. So that's the next. That's the smallest. That's the next smallest. Think about money. That's not even a cent. That's a little bit closer to a cent. That's 55 cents. That comes next. Did I misread that number? Oh, 0.055. It's still the next smallest. I just miswrote it, and I apologize. Okay, well, so what comes next? Well, we have a couple more. We have 55,000, 5,500, or 55 billion. Well, 5,500 is definitely next, so that's going to be 55e, 5.5 times 10 to the 3rd power. Next is going to be 55,000. That's just written in a form that's okay. And this guy is 55 billion. Let's say I have one too many box here. No big deal. Okay. So ordering numbers, you really have a choice. Do you want to take everything and put it into scientific notation first, and then try to order it by looking at the powers, or do you want to write everything out into standard form where the numbers are a little more natural to order because we're used to it? It's your choice. I'll be honest. I prefer doing the scientific notation because I just look at the powers. Over here, you saw the kind of mistakes I was making. If they're common, transferring the decimal around and then trying to reorder just takes a little extra time. Your choice, though. You do what you want. Next problem. Actually, I'm going to go ahead and end part 2 here, and then I'll start part 3 here in a second.